So thanks for having me here. What's interesting is this event is exactly why or my motivator personally for starting Cumulus Networks. I've been in the networking industry for almost 20 years. It's kind of embarrassing, super old school. You know, Ethernet started off as like a cable this fat, and we used to have to crawl in the attic and put vampire taps in there. If you don't know what either of those two things are, you can't talk about networking. That's old school guys. We're still alive, goddammit. Until we die, you don't own networking, we do. You know, all things aside, I worked at Cisco for a really long time. I worked in development groups, and we would spend tremendous amounts of time doing this really cool thing called QA. When we developed a product, we had to ship it out to customers. And we would go through this massive kind of battle year after year after year of, can we automate this stuff? Can we automate our QA? No, we can't, so we have a bunch of people manually doing stuff. And the reality is, when you're doing manual QA, things aren't repeatable. You know, when you finish and ship a product, you think you tested everything in the test plan, but maybe there was a gap. And the next time you do a software release, you got to go back through and do that whole same gap again. And you know, we started trying to build automation frameworks, and we just couldn't do that. And I kept getting more and more frustrated as I was helping develop products. The products themselves were good, but the technology that we cared about as a company wasn't moving along with even the things that we needed internally to be successful. I was lucky. I got a chance to work at Google for a period of time as they started getting into networking themselves. I left Cisco, went straight into Google there. I was super excited because Google is clearly a very innovative systems company, and I looked forward to being able to evaluate networking problems kind of end to end, from a platform, the interconnect, the cabling, the physical manifestations, all of those areas. But what's important here is the motivators. Why did Google do their own networking? So part of it was the really obvious part, which is, you know, Steven Stewart was my boss at the time. He says, this is really simple. Cost me $1,500 to buy a server. I need my whole network. I need full bisection bandwidth. This is back in 2005 at a gigabit Ethernet to the server for $150 for 10,000 servers. That's cost. So he needed cost to be his #1 motivator. And so I said, okay, great. Made sure we understand all the parameters around that. And he goes, okay, cool. Now let's throw that away. So that's a given. You have to do that. And if you fail at that, you suck. Over here, we at Google have a huge amount of tooling that we've developed that allows us to deploy, monitor, configure, diagnose, and troubleshoot applications and physical infrastructure. And there's only one element we have right now that doesn't fit in that mold. Anybody want to guess what that was? Can I get a networking from the crowd? Networking, it didn't fit. So they'd been working with, you know, a couple incumbent companies, and the platforms were too closed. Steven's a super smart guy, he's run internet exchanges. He gave me his really killer Perl script that he was using to deploy a pod, and it was, you know, it was actually for Perl pretty well written, but it was super brutal, not very functional, and it, you know, we'll get to this a little bit later on. It didn't address the areas that Steven really needed addressed. They wanted the networking platform to look much like a server. They wanted to be able to have different constituencies drop on a monitoring application that didn't know about all the other monitoring applications. They didn't want to have you know, the classic model of an SNMP collector to collect all the data, then figure out who to distribute it to. That doesn't scale. So in today's parlance, they had a piece of technology very similar to Nagios that would monitor things like, you know, CPU overutilization, power supplies or fans dying, and that would send a pager alert to someone that says, get your ass in there right now and fix something. They had a whole nother parallel infrastructure that looked at things like network link utilization. Didn't know that the Nagios thing was going, didn't care about it. They just looked at network link utilization, did a bunch of on-box processing, you know, kind of form-fit, really rapidly taken data, figuring out what really mattered. You know, anything that was kind of normal, fit within the parameters, they would just update really slowly and periodically. If they started getting a lot of bursts of traffic, they would update faster and feed it back to a collector. And then they would post-process back on the collector. Super scalable bandwidth monitoring application. One of the teams was trying to figure out, in the context of a specific application cluster, what do the connections look like between servers? What are the connection rates? How do they affect network capacity and utilization? So they started looking at counting things like sends and acks and resets and TCP. Totally another monitoring application, separate from everything else. That was an operational environment that makes sense to Google. This is an operational environment that's completely foreign to almost any other networking environment that you know today. This was one of my motivations. I left Google, went back to a little startup called Nuova Systems, and we got subsequently acquired by Cisco. And the product that I worked on was the unified computing system. You know, you may love it, may hate it, but if you're an enterprise customer and a couple years ago or even today you were looking for a blade type compute environment, it's a pretty good solution for that set. It's kind of best of breed there. One of the things that made us successful with UCS was we went through and tore apart the whole inside of a blade system, and everything. We had an application which is the UCS manager. It's kind of built in a very DevOps type mindset and framework, state machines, interactions, great big object model, all that cool stuff. Every other piece of the system was a Linux endpoint. So the chassis manager was a Linux endpoint. The baseboard management controller on the servers, Linux endpoint. The NICs, we built our own NICs, they were all Linux endpoints. We would take Linux images and put them on the bare servers and use them to diagnose the system, base provisioning, all of those sorts of things. So when you plug a blade into UCS and you go through and figure stuff out about it, what happens under the covers is there's a full image deployment, bunch of testing to make sure everything's connected up, bunch of data is pulled off of the platform, passed up to the UCS manager. If it gets deployed, that same image is used to do any hardware-specific configuration, gets taken off, and then you image it without whatever the customer wants to put on the platform. It all works because every endpoint in the system was a Linux endpoint. Guess what our biggest pain point in the whole system was besides BIOS? NXOS. The one piece of technology that Cisco walked into the door with on this product was the biggest pain in the ass that we had. We did a huge amount of development and work to try and make NOS slightly, acceptable and work out here. And it was a massive nightmare. Huge numbers of people spent time on this. So this is my fundamental motivator. I'm not going to give a product pitch. I just want to talk to you about how important it is for us at Cumulus Networks to participate in this exercise. I wouldn't say we're leading the way. I would say that it's near and dear to our heart. At the very bottom of the orange, that's a pointer to our GitHub site. You can kind of go see a bunch of the projects that we kind of host ourselves. But most importantly, across the org, top to bottom, anybody that's technically minded is involved in some way or another in contributing back to making networking easier in the context of an open platform. One of the things that's kind of, I'd say, important or philosophically ingrained in us is we view ourselves as an operating systems company, not an appliance, center of the universe company. And as an operating system, your job in general is to enable other people to do what they need to do to get a job done. So we look to enable the operational community to deploy networking in a way that meets their business needs. Kind of super simple, but that's really what we do. We have, like I said, pretty much every group in the organization makes contributions. The GSS, that's our support team. We have a CEng team that does a ton of work. The dev people contribute back, kind of up and down the stack. The CTO and a couple of other people in the CTO's office contribute. We have some projects that we've done ourselves. We've gone back through and worked with pretty much all of the base configuration management and monitoring applications. I just put a few examples up here. We've worked on dumb things like OS detection, the ability to, Puppet's a great example. They didn't have a build for PowerPC or a very good build for PowerPC, so we helped them with cross-compilation. Same thing with CF Engine. Then we've gone back through and done what really matters, which is to create content. Some of the content is demos and examples and that kind of stuff, call it fluffy content. It's useful but fluffy. Some of it is actual customer-generated content. We have customers that come to us and say, I want to automate my networking. Show me your demos. And so we'll run them through, let's say, sometimes they're really naive. We'll run them through all 4 of the common configuration management tools and say, okay, here's a palette that you might be able to choose from. They go through and say, well, this is the one that makes some sense to me. Let's dig a little bit deeper here. And we'll go through and show them what we've done under the covers. And sometimes they'll come back and say, hey, help me automate this particular operation within that tool framework. So we help them out there. For those of you that are interested to go a little bit deeper, if you go to our website, there's this thing called the Customer Workbench. That's how you can remotely evaluate Cumulus Linux without buying anything and through the web. That's a fully automated environment. It's one of those classic things where if you're a customer, you come in, you get your scheduled date, you log in with your credentials. When you hit the go button, whatever was there before gets wiped out. Everything gets rebuilt just for you. You do your thing. When you're done, it gets wiped out and given to the next guy. It's a completely automated deployment. And the last thing that we're doing, I'll talk about this a little bit later on, is we're moving the needle on creating structured I/O for common Linux packages. So how many here are familiar with Puppet, just for the sake of argument, or Chef? Pick any one of those two, Puppet or Chef, right? So you know that there's some module that does ISC DHCP for the sake of argument. That module works, it's there, uses the classic text files available for ISC DHCP. But then you're a moron like me and you say, why aren't we talking to that thing in JSON? What's the problem? Why does this not work, right? And the answer is, because no one's written it yet. And we're going to get to that later, because that's kind of one of my impassioned pleas here. So the first thing I want to do, as Jeremy's laughing at me, and I'm not sure if he's going to bitch slap me later on or not. But I have a set of impassioned pleas for the rest of the discussion. One of them is that I think there's a myth of a universal data model, and I bring this up because there's a collection of kind of like-minded and interested individuals here. I'm sure that many of the people here are going to help move the industry forward. What I'd really like to do is avoid an open daylight or even an open flow here, where someone says, we're going to write a standard that tells everybody exactly all the possibilities and how they program those possibilities in this cool new world. Sounds great on paper. It has never in the history of mankind worked. Look at every ISO standard. Actually, here's the great example. If you're a networking person, compare ISO to IETF. Again, I grew up in the old days, right? So a lot of my friends are old deckheads, and I would listen to them bitch. We had the coolest networking standard in the world. It was so awesome. It did everything that you ever needed, hierarchical naming, flexible address spacing, all this stuff. And I have all my other friends that, hey, dude, our stuff worked, and we deployed it, and we were out the internet. And so the IETF effectively won because it was consumable and it was distributed. A lot of different people worked on it, very, very, very smart people. They worked on it, they made things move and work. They got rid of the universal data model in the interest of making progression in the system. The way I would urge you to look at this thing is to create what I call localized truth. I brought up the example of ISC DHCP. Why doesn't it have JSON? Because no one's written it. Could you write it? I bet at least 30% of this room could sit down today, and in a month from now, ISC DHCP could have structured I/O. This is not rocket science. This is eminently doable. So as part of the contribution that you or your organization or one of your peers wants to do, part of it is kind of creating that environment that makes it easy for the next guy to come on and leverage tools like ISC DHCP. And I bring that one up over and over again because if you look at networking equipment, this is DevOps4Networks, that package is the foundation for DHCP on every networking platform. Junos, Cisco iOS, NXOS, Arista. How much of the functionality of that platform do you get access to as a consumer for any of those companies? Pretty much zero. Pretty much zero. Linksys router uses ISC, some of the routers use ISC DHCP. What they've done is the CLI, and this is going to kind of lead into the next part, the CLI has put a guardrail around what you're able to leverage and use. In the context of DevOps for networking, it's really about having platforms that remove the guardrails and allow the operational staff to develop the functionality that they want with the guardrails that are appropriate for their organization. That's really the fundamental driver here. That makes the transition into ops with guardrails. Super important. I know John was talking about software developers and the software development methodology and mindset. How many of you here would you consider yourselves hardcore software engineers? Okay, like hardcore software engineers. A few of you are here. So if you're a hardcore software engineer, it'll be interesting to watch there. Everybody look around, raise your hands again if you're a hardcore software engineer. I'm gonna speak what I believe is a universal truth, and I want everybody else to look at the hardcore software engineers and see what their heads do. Okay, when you write software, better than 50% of your code is making sure somebody else didn't screw something up. It's defensive programming, right? And what I've noticed oftentimes when people write operational software with a DevOps mindset, sometimes we don't really take that and understand that's our responsibility. Our responsibility is to make sure that when I have operations, I'm able to, because remember, DevOps isn't about the dev part, it's about the ops part. You're getting paid by whoever's paying you to make sure that the business runs, not to write cool infrastructure. The cool infrastructure makes the business run, right? So that's the relationship that matters here. Make sure that you do development in the context of bite-sized chunks, things that are eminently reviewable. You know, I talked about our contributions. We have these environments, and we spend a huge amount of time on this. Bite-sized chunks, send them out. A lot of people comment on them. You get a lot of global review. One of the things that I've observed about the Linux kernel itself is everything gets discussed in the context of patches. And one of the characteristics of the Linux that's very much overlooked is that when I submit a patch to the kernel development team, I'm getting review from some of the best software programmers in the world. So the probability of maybe making a fundamental architectural mistake is pretty much zero in the end, because everybody cares about what comes out, and they really know their craft well. And the second part is super important, is defensive programming. I don't know how many times I've talked to somebody that said, yeah, we automated VLAN deployment in our environment, and it blew up. And I'd say, well, why did it blow up? Well, because we started deploying overlapping VLANs on a bunch of other stuff. And I'd say, why didn't you have a check at the beginning of your thing that said, is this VLAN range already deployed? And they go, oh, maybe that would have been a good idea. Right? And I mean, you're chuckling, but I'm not bullshitting you. That's what happens. So the takeaway here is, as you're developing operational code for your companies, focus on defensive programming. That's what really matters, because again, this whole exercise works when infrastructure is easy to deploy and it works really well. So in the end, that's really what I wanted to talk about, kind of a little about why we started Cumulus Networks, and the fact that the DevOps, or specifically DevOps around networking, is a fundamental for us and why we exist. And really those two big mantras around DevOps in general. It's not universal data models suck, focus on bite-sized chunks and locality, local truths, and then ops with guardrails. Those are the big focus. Thank you.